Welcome to the second Another Peak Prismo Systems webinar with myself, Chris Reed, and Mark Sainsbury, Head of European Sales for Prismo. Today we are looking at the right-hand side of the Another Peak playbook, looking at risk, compliance and estate planning. And today we wanted to run through a Prismo demo based on a proof of concept with an insurance company. Now, security is complex and very resource intensive. Organizations either have their own security teams or they rely on third-party service providers. In this case, our client had an in-house team whose remit had expanded due to COVID and home working. So they were facing some very challenging environments. They had a range of traditional security tools to address various threats, but parts of this process were manual and repetitive, and they also lacked a management level view of what was going on. So the Prismo challenge, if we can call it that, was to automate around the corporate security policy, to provide technical and management visibility of both the inherent and the imminent risks and do that in real time. And in so doing, highlight the benefits of a transactional approach to security. And I come back to the root admin example that was highlighted about a year ago, that, you know, the root admin hacker has about 20 minutes to make themselves invisible. And that always involves some form of transactional activity, which traditional security solutions may not spot, but Prismo does. So at the end of the day, we had a proof of concept. The duration was 2 to 4 weeks. Full Prismo support and discovery consultation was part of that service. The clients, the agents were deployed within the client's cloud environment, and the minimum deployment for this particular client was one agent. In this case, we targeted a Linux server. We had 3 VMs to run the database, the analytics and the UI, but that could be in theory combined into one. And we had access to Active Directory and NetFlow. So without hesitation, I will hand over to Mark.
So I'm going to just run through a relatively small part of the platform, but probably one of the most interesting, and certainly the part that very often clients get a lot of unusual information that they weren't expecting. So we're looking at the Assess tab, and in particular the risk assessment dashboard. The dashboard is actually divided into two. We have the imminent risk dashboard, which is essentially external factors out of the control of the client, and is primarily based on either policy infringements or transactional activity that's deemed to be malicious by the automated algorithms that are running in the background of the Prismo platform. So I'll come back to that at the end if we get time. What I want to focus today really is on the inherent risk summary. So this is information that's automatically discovered by the platform in conjunction with the agent that is residing within the server or the host. A server can be Linux or Windows, and we've got a mix of them here today. And what we're able to do is to extract information and then produce it in real time for the client to assess the risk profile of what often is known as hygiene factors within their IT estate. So we'll look at some of them. Not all. We've currently got 12 applets running on the system, showing us various parameters that we feel are likely to be a target for a threat actor to exploit. Some of them are relatively obvious. So, for example, we're doing some very simple, quick, and easy analysis of the software packages running on the server, and any known vulnerabilities that may be currently live. We put them into their usual low, medium, high, and critical categories. You can click on these at any time and it will give you a breakdown of the particular server, the package that we've identified and the version that it's running of the operating system. In this case, we're running CentOS. You can also click in here and get some more detailed breakdown of what the vulnerability is, how it affects the system, etc.
Right, so you can really drill this down, can't you, into not only is it critical, but why is it critical and the reason it's critical. Yeah, excellent.
Yeah, and you can look at the different levels. Typically, clients are focused on the critical and high. One of the challenges we know around patching vulnerabilities is that there's often a time lag between the vulnerability going into the public domain and the ability of the client to either apply the patch or organize downtime, etc. So what we've installed here is the ability to create a simple policy that allows you to either alert or block on a transaction that's going to instigate a session that will expose that vulnerability to the organization. So literally a couple of clicks, you can choose your sorry, I'm changing the one that we can choose your criticality.
Okay.
And say that, if a critical vulnerability in one of our packages is going to be exposed, then either deny that transaction altogether, or more likely you're going to allow the transaction but create an instance so that your SOC or your vulnerability team is aware that that particular vulnerability is now in play within the organization.
And again, because Prismo uniquely can look at the transactional activity across the estate, you're able to do this in real time. Yeah.
Exactly. Yes. And the advantage of the transaction is that you get the full context from end to end, from the user through the network into the hosts right through to the application. So you're not having to try and second guess what's happening at a particular point in the transaction. You're looking at the full transaction in its full context. So it means that we're less likely to have a false positive. Moving on to some of the other outlets, we've got other aspects that we are likely to see as potential targets. We've got, again, this is quite an interesting one. We record and analyze the installation accounts that we find within the servers, not just what they are, but who's using them. And again, we've got the ability to create a policy that says, that nobody can install an executable unless they follow the correct workflow that the company has defined as their standard policy. So in this case, we'll say we're going to use Yum as our default installer application. So very quickly we can first of all identify who and what is installing executables on our domain, and then put a policy in to restrict that to minimize the exploitation. And people downloading malware or ransomware, for example. Again, it's about narrowing that exposure to executables. We look at things like server to user connections. Again, not always, but very often can be an early stage evidence of malware exfiltrating data. You can look at the complete data patterns of each of the end-user connections, so you can do detailed analysis about which servers is calling out and what protocol they're using. Again, you can look at all of the connection DNAs. I've only got one on my system here, but you get a detailed breakdown of exactly what's happening if you needed to. I'll pop back from that one. We look at things like lateral movement. Again, another early stage evidence of potential infiltration and evasion. We're looking at external connections. Why are servers calling out to the internet? What servers are they? Again, we give you a breakdown of the servers and a complete detailed breakdown of the DNA pattern associated with that server, so you can see what's been happening in some detail for that particular server.
So again, this all goes back to effectively a corporate policy, doesn't it? You have a compliance policy, and what we're doing in the proof of concept is A, discovering what's out there, and then B, mapping it back once we've done the discovery.
Yeah, what we very often find is that the client's policy will be that there are no external outgoing connections. However, we do the search and find that they are actually happening. The client just doesn't know about it. Okay, so a lot of this is about identifying the blind spots, shining a torch into the dark corners and finding out what's really happening and comparing it to what you think is happening. And then giving the client the ability to drill down and focus into the areas where, they feel the most risk is.
That lateral movement comes back to the original in my introduction when we were talking about root admin hacking and that 20-minute window to laterally move across and make yourself invisible and therefore then harvest at will. And that's what the user lateral movement's about, yeah.
Exactly, yeah, absolutely. And then at the bottom here, we've got some more information on privileged users. Looking at it from a user point of view, we can look at it from the other way around. We can look at root service accounts. Here we've identified a total of 11 service accounts. None of them are root on this particular one. We've got a number of privileged users here. Again, very easy to identify who those privileged users are. And in a moment, we can have a look at exactly the risk score of the individual users from their point of view rather than looking at it from the risk parameter point of view. We'll come back to that in a moment. Shared accounts, unused local accounts, and unresolved IP addresses, all parameters that we know can be exploited if not correctly managed and controlled. What we can do then is we can sort of kind of drill down to the next particular, next layer and look at, the individual risk score of the users or resources. So from a user perspective, we can look through and have a detailed breakdown of every user on the system, a detailed analysis of who they are, where they are, etc. What groups they fall into. There's a risk score for each user. In this case, it's we've created a dummy user with a very high risk score. But we can see that actually this person, is a high risk user. They've got access to a number of local accounts. So they've got privileged access. They're using multiple devices. One of the devices is a corporate laptop. The other is a private iPad. Again, we can click on these and delve down and find out additional information. The reason the iPad is rad is because there's no security patch running. Okay, so if you look at the corporate device, there's a security patch and it's a corporate device. So very quickly we can build a profile of this individual and identify whether there's some additional steps need to be taken to protect this particular profile or to restrict the activity of this particular user to narrow that potential.
And this was important in the proof of concept because of the increased number of home workers that the client had that he wanted to see, get a better view because it's suddenly half of his workforce are remote.
Absolutely, yeah. So you get a very forensic view of your user community and not only what they're doing, but also what they're not doing. So we look at, not only the top external connections, but also the rarest internal connections. So we're taking two views of the world, what they normally do and what they rarely do. What it allows us to do is to kind of create almost like a DNA record of behavior against which you can either create a policy or the algorithm can start looking for anomalous behavior. And here we can see that few ways actually been using the VPN, but not for all of his time. So again, there's some investigation to do there. So why is 43% when he's clearly working at the moment? And then access to what files he's accessing, and again the rarest files he's accessing. So you get a detailed breakdown of each individual. It's constantly updated, and anywhere you see the blue link, this is a link to additional detail behind the scenes that the analysts can jump into if they wish to. We can do the same for the servers, similar format, but looking at things from a slightly different view. I'll just try and find one here that's not very interesting. Okay, so again, we get a detailed breakdown of the server. In this case, it's a virtual machine.
Yep.
We get information on the host, the operating system, all the sort of thing you would expect to discover when doing this type of analysis. Again, you get some initials on the risk trend score, some breakdown of the incidents associated with this particular server, and we can see there's been a lot of outbound connections which we've generated for test purposes. But again, very simple to identify when something's happening that would be unusual and would need further investigation, and the sort of thing that can go on undetected within an organisation, for many months. Mm-hmm. Again, we're looking at top internal and external connections, and then we get a detailed breakdown of the risk exposure for that particular device. So again, we're looking at what installation accounts are configured, servers accounts, local accounts, and what packages it has. This actually, for some reason, it's not picked up the packages. Not quite sure why, but so again, you get a detailed breakdown, and you can look at these in whichever way you wish. So at the moment, we're looking at it.
Okay, so we can see it in the public or private cloud environments. Yeah.
The system completely instruments above all of that, so it really doesn't matter whether the clients got private data center, cloud, or multi-cloud, or what most people have actually is a hybrid environment. Mm-hmm. We can abstract away from that and use this visibility end to end without having to delve into the individual hops and jumps of the infrastructure underneath it. Very quickly then, back to the imminent risk summary. So whereas the inherent risk summary are known aspects of the infrastructure that are under the control of the client, if you know the door is left unlocked, you can take some actions to lock it. The imminent risk summary are unexpected events that are happening that are outside of the control of the client, so difficult or impossible to predict. And some of those things are obviously, advanced persistent threat attacks, malware, policy violations. So we have a method of monitoring the traffic constantly, and the algorithms sit in the back along with the policy engine, looking at the transactions and making decisions as to what may or may not be good or bad. So we've generated some ourselves for demonstration purposes. So if I jump straight to the imminent risk dashboard. First of all, you can see from the top here, we have a number of algorithms running. Some very simple, monitoring the connections from server to user, others more complex. So, for example, doing analysis on command injection vulnerabilities within operating systems. But all of them are fully automated, so there's no configuration and they run constantly.
And I think that's an important thing, isn't it? As we said, that, for the proof of concept, they had issues with the sheer amount of resource for all these manual activities, and what Prismo are doing is just automating the whole thing.
That's right. Traditionally, with IDS systems, web application firewalls, you'd have to spend a lot of time creating complex rules, and that's because they analyze traffic in transit, if you like, and what they don't have is the full context of the end-to-end transaction. They don't actually understand what the architecture of the host and the application is, and whereas we do. So we're actually sort of looking from the outside, from the inside out, if you like. So we can actually make some decisions because we understand the structure of the application and the host it's running on. So we don't need to configure the algorithms specifically. The algorithm actually can learn that information and make the decision itself. So it means that the algorithms are essentially standalone pieces of code. So what we've got here essentially is we've got the algorithm name. In this case, it's the reverse shell algorithm has been triggered, and we give you some information on the MITRE tactic and technique, which you can link back to the MITRE website for additional information. We then give you a breakdown, high-level breakdown of the actual alert. In this case, we give you the source, and we've identified the actual individual, and this is Ruben, who's actually one of our developers, so that's good news. The target, which is our test server. We've identified what the remote server IP address is and the reverse shell client that's being used. We've also, in this particular alert, given you the automated action, and we've actually terminated the process. So when alerts happen, clients have the option to either automatically terminate the process if it's of a serious enough nature, or just to log the event and create an incident for the SOC team to investigate. And again, anywhere there's blue, it means there's additional information behind. So if we're wondering who Ruben is, we can click on the link and we jump back to the user profile we saw earlier, where we've got a detailed analysis of Ruben and him as an individual. And this is useful when you're identifying either somebody within the organization doing something outside of the policy, or perhaps this isn't Ruben at all. It's somebody who's managed to get hold of Ruben's credentials and is logging on and carrying out malicious activity in their name. Okay. Again, all of the algorithms generate alerts in similar format. The one thing that we can do is with all of these is you can jump down to the next level of detail by clicking on the trace event at the bottom here, which takes you inside the actual processes themselves and running. So again, if you want to delve down into a more forensic level of detail,
right? Yeah, yeah,
very useful when looking at post-incident or just figuring out why the alert has been generated in the first place.
So Mark, thanks very much for that. Thanks for the presentation. Hope it's of interest to the audience, and we'll get you back soon to do a few more Prismo demos.
It's a pleasure, Chris. Thanks very much again.